Welcome to your next quest. Now we know that we need a data asset for our level up info. Now your quest is to create one and add an array of structs to your level up info so that we can have the amount of information we need for each level up. That includes level up requirement, attribute point reward, and spell point reward. Now as a bonus, you can make a function to find the level for a given amount of XP. So you pass in the amount of XP, and the function will find what level you should be at for that amount of XP. Remember, XP is cumulative, right, over the course of the whole game. So if you're up to the extra challenge, figure out how to find that level for a given amount of XP. So pause the video and conquer this quest now. Okay, so we need a data asset. That means we're going to go into C++ classes or a public. And I'll put this in ability system data with our other data assets here. So new C++ class, we're going to create a data asset and click next. And this can be called level up info. So we'll create the class, we'll close the editor, and we'll define it here. So let's go to public ability system data. We'll open level up info and close all other tabs. I'll go ahead and get both CPP and H files open. And here in the header file, the first thing we need to do is create a struct, right? We need a struct with our level up info for each level. So we'll go ahead and create that struct here called F or level up info. Now this will be a uStruct with blueprint type. It gets a generated body, and we're going to have basically three values here. We're going to have a level up requirement. And for level up requirements, this is a number, an amount of XP required in order to level up. Now for XP, I'd like to use discrete numbers, integers, rather than floats. So it's kind of cut and dry whether or not you have enough XP to level up. You have a number of points, and if you don't have enough to level up, then you don't level up. So for that reason, these are going to be integer numbers. We're going to have an int32, and this will be a level up requirement. And we'll give it a default value of 0, but this will be designed to be set from our data asset for each level. So it's going to be edit defaults only, and I don't see an immediate need to expose it to the event graph. Now, in addition to the level up requirement, I'd like to know how many attribute points I should be rewarded for leveling up to this level. So I'm going to make an int32 called attribute point award. And by default, it'll be 1. And this will make it easier if most of the time we just want to gain 1 attribute point when leveling up, then for most of these, we won't have to change it. And then every once in a while, perhaps we can get 2 attribute points for leveling up, and so on. And we haven't created any spell points, but we're going to. So when we level up, we'll be able to spend points on spells as well. So I'm going to have another int32 called spell point reward or award. Either one is fine. Award sounds like you're going to be awarded this many attribute points, but we could call it spell point reward. And then it's like, this is your reward. I don't think it's terribly important which one we use. So I'm going to call it spell point award for the amount we award someone when they level up. So now that we have this Aura level up info, we need an array of these. So we're going to make a public section and make a T array of F Aura level up infos called level up information. Now this will be filled in the blueprint. So edit defaults only it gets. And we have our data asset. Now for a bonus, we had the task of creating a function to find the level for a given amount of experience. So what we can do is make an int32 returning function called find level for XP, where we take an int32 called XP and return what level we should be at for that amount of experience points. So how are we going to do this? Well, we have level up information, which is a T array, and the index for our T array is going to be the level, right? So level up information indexed at 1 will contain the struct for level 1. Now, because we're indexing by level and not by, say, the level up info in a map, for example, we can't just do a random access lookup. We're going to have to go through the array until we find the correct level. So a simple algorithm would be to create some kind of a loop, like a while loop. And while can search through the array until it finds something. So I can make a Boolean called bSearching and set it equal to true, and execute the while loop while bSearching is true. So while bSearching, and then at some point we can set it to false as soon as we find the correct level up requirement. Now we need to know what level to return. So I'm going to create a local int32 called level, and we'll start it off at level 1. And in our loop, once we're done with our loop, this should be set to the correct level, and we'll return that at the end. So we'll return level at the end. So the question is, what does our loop do? Well, the first thing we should do is check our level up information and make sure it has enough elements in it. In other words, we should say if level up information dot num, like how many elements are in the array, if it's less than or equal to level, then we should return. Why? Because, well, let's say level up information is empty. It has 0 elements in it. Well, level will be 1, and level up information dot num will be 0. So in this case, we should just return, and we'll return level. We'll just say 1 in that case. Now, level up information should at least have 1 element in it, and if it does have exactly 1, well, then we should also return level, because that's the only level that we have stored in there. Now, if it has 2, for example, then level up information dot num will be 2, and that's really just for elements 0 and 1, and the convention that I'd like to use is that first element in level up information will correspond to no level. It'll be just a placeholder so that element 1 can be for level 1. So in the case that level up information dot num is 2 and level is 1, well, in that case, we want to return 1, right? So really, we could have level up information dot num minus 1 here. Now let's think about this if level up information has 3 elements. If level up information has 3 elements and level is 1, then level up information dot num minus 1 is 2. That is not less than or equal to 1, so we would continue. So what we can say here in a comment is level up information at 1 equals level 1 information, right? And level up information at 2 equals level 2 information. So this means that level up information at 0 is meaningless. It's just a placeholder. Okay, so if we reach past this return, then that means we're going to need to search and see what level we should return. And that's going to depend on XP. So what we can do is make a check. We can check if XP is greater than or equal to level up information at the level. Now, level up information at this level returns a struct. So if we use the dot operator, then we can access that level up requirement. That's going to tell us how much is required to level up at this particular level. So we start off with level equals 1. We're assuming we have enough elements in level up information to search it. Now let's say that XP is, say, between 0 and 300. In other words, level should be 1, right? Well, level starts at 1 here locally, and XP, let's just say it's 100. That means we should be level 1, right? Well, if we look up the array, indexing at level 1, and we get that level up requirement, that should be 300 for level 1, which means that XP is not greater than or equal to level up requirement. So in that case, we can set bSearching to false and exit the while loop and return level. So we can have an else case here that says bSearching equals false. Now, what do we do if we make it to the inside of the if statement? In other words, XP is greater than the level up requirement of our current level. Let's say the amount of XP is 400. That's greater than the level 1 requirement, right? So what we can do is add 1 to level. We can say plus plus level, and then our loop will start over. So if level up information has enough elements in it, level has just gone up to 2, right? That means level up information should at least have 3 elements in it. If it does, 3 minus 1 would be 2. That would be less than or equal to level, which would be 2 now, so we'd return level. See how that works? But if level up information has way more than 3 elements, let's say it has, say, 10, well, then we won't get past this. So what we'll do is we'll check our condition again. XP was, we said 400, and we can check now against level up information at level 2. Now, let's say at level 2, the level up requirement is 900. Well, in that case, we would not reach the inside of this if statement because our XP was 400. So we would get to the else, B searching would be false, we would exit early and return level. So this gives us a function to search through the array and return the correct level. And yeah, it's a while loop, so the maximum number of iterations would be the length of our T array. And this also allows us to see what level we should be for any XP amount. So if we're at level 1 and we gain 1,000 experience points, if that's enough for a double level up, we'll know because we'll know what we were at before, we'll know what we should be at now. If that's 2 levels or 3 levels up, then we know we got a double or a triple level up and so on. So now that we have level up info, all we need to do is make the blueprint. So let's compile and launch the editor and make our data asset blueprint. Okay, so let's make our blueprint based on level up info. I could go into blueprints, ability system data, right click, go to miscellaneous and data asset, and we can search for level up info and create a data asset based on that. We'll call it DA level up info. Let's open that up and we have an empty array. Now if we click plus, we know that the 0th element is just a placeholder. So we're not going to set anything here. We want to click plus again and we'll have our level up requirement for level 1. So again, we could have used a curve table for this. I'm not. I'm going to use this way because I like to set things manually just in case we want different values. And I don't want to have to create curve tables for multiple things. All I have to do is add to this struct if I want something else to put in this data asset per level. Now, for level 1, I want my level up requirement to be 300. We'll likely create some kind of a placeholder level up info for testing so that we can level up much faster. But 300 XP to reach level 2 sounds good to me. And I'm going to click plus a whole bunch more times so that I can have level up requirements for levels 1 through 10. Now, how do you choose these values? Well, one way is to take a look at other games. Another way is to kind of ballpark estimate. Another is to just fill this in as you go, as you're play testing. Now, there are lots of other popular role-playing games. Some are video games, some are tabletop RPGs, and there's one pretty good one you could use as a reference. It rhymes with Dungeons and Flagons, and I'm going to use numbers that are similar to that. So my level up requirement for level 2 is going to be 900. For level 3, it's going to be 2700. For level 4, it's going to be 6400. For level 5, it's going to be 14,500. And at level 5, I'd like to gain 2 attribute points and 2 spell points. So now we can see that we don't have to just get 1 point every time we level up. We can change this. So level 5 is a special level up. We get 2 points, right? So we can do something special like that. For level 6, I'm going to have a level up requirement of 20,000. And for 7, it's going to be 35. 50,000, that is. For level 8, I'm going to go ahead and go up to 50,000. For level 9, it's going to be 65,000. And for level 10, it's going to be 85,000. So now you can see that a mathematical formula might be hard to manage as the number of levels increases, but manually setting these makes it a little easier. And this is kind of cool because you're seeing that as the game progresses, as your character gets higher in level, we're dealing with higher numbers here. At first, you needed a measly 300 experience to level up to level 2, but when you're level 9, you need 65,000. But then again, you'll be slaying monsters that give you a higher number here. So this is one of the ways that RPGs can make you feel a sense of accomplishment. You're capable of gaining much higher values for your XP, which is quite nice. Okay, so now that we have level up info, that takes care of that step. And we'll continue in the next video with the next task. I'll see you soon.